Hello and welcome. In this video, we'll be taking a look at the next section of notes, which is solving systems of equations using substitution. So before we begin talking about that method for solving systems, I want to provide a little motivation by looking back at what we did in the last section, which was solving systems of equations using the graphical method. So I've created an example, much like what we did in class when we were solving these systems of equations using the graphical method. So you'll notice that I've got some dots on my graph. Some of them are blue and some of them are red. The blue dots represent this top equation, which is y equals 4x plus 1. So you'll notice that I have a y-intercept at 1, and then my slope is 4. So that's telling me to go up 4 and over 1, up 4 and over 1. In red, I've graphed the bottom equation, which is y equals 2x plus 2. So you can see I've got a red dot at 2 on my y-axis, that's my y-intercept, and then I'm going up 2 and over 1 because that's what my slope is telling me to do. And so what I'm going to do is just graph out these two lines. So I'll do the red one first. So in red I get something that looks roughly like that, and then in blue I'm going to get something that looks sort of like that. So you can see where these two graphs cross. I'm going to circle that in green. It's about right there. The problem is when I look at the coordinates at that point, they're not whole numbers. The x-coordinate seems to be somewhere in between 0 and 1, and the y-coordinate, now it looks like it might be a whole number. It looks like it might be 3 or so. So this is one of the problems with solving systems of equations using the graphical method, is that oftentimes where the two lines intersect are going to have coordinates that aren't whole numbers, or even integers for that matter. So a natural question for us to ask is there another way for us to solve these systems of equations? And that's exactly what we're going to look at in this section.